Good morning, students. Today we are going to discuss about domestic electric circuits, right? Domestic electric circuit, right? In last class, we discussed resistors are parallel series, okay, that and all. Okay, students, shall we go to the topic? Okay, now come to this one electric circuits. Some details about circuit, right? See the first point. Electric power is usually generated at places which are far away from the places where it is consumed, right? So electricity is generate generation places is far away, right? But we are using the electric power. Okay, now see the second point. At the generating station, the electric power is generated at 11 kilowatts. So this is kilowatts, right? Yes, 11 kilovolt, not watts, kilovolt, right? So this voltage alternate at a frequency of 50 hertz. So the frequency of the current is 50 hertz. Hertz is the unit of frequency. Okay, students, right? The power is transmitted over long distances at high voltage to minimize the loss of energy in the transmission. Yes, so here we are transmitting the power at high voltages. Yes, due to reduce the loss of energy. The loss is nothing but heat. Okay, okay, students, because when the current flow through the wire or conductor around the wire, what will happen? Current will be heat will be produced. That the heat is nothing but loss of energy. Okay, that's why the power is transmitted over long distances at high voltages. Okay, students, right? Now see this circuit. Yes, this is the simple domestic wiring circuit, right? And see the first point. The electric power line enters our house through three wires, namely live wire, neutral wire, and the earth wire. Yes, so three wires, right? And to avoid confusion, we follow the color code for insulating these wires. So all the electric circuit has using color code is wires, right? And now come to this one, second one. The red wire is the live wire, that is positive, and the black wire is a neutral. Yes, and see this one, live wire and the neutral wire, and the earth wire is given green plastic insulation. So this is the green plastic insulation, right? And see, this is the live wire pass through main fuses, the neutral wire, and this is the meter, 234 kilowatts hour. kWh is nothing but kilowatt hour, right? And this is the main switches. In the earth wire is common, earth wire is common, and see this parallel appliances. So in our home, the electric circuit is parallel combination. Electrical connection is nothing but parallel combination. All the switches and all the connections are parallel. Okay, students, right? And this is that same diagram. Yes, live wire, neutral wire, main fuse, electric meter, main switch, and the parallel combination. This is the each yes switches. Okay, so for example, one for bulb and one for fan and one for charging point, or otherwise some other applications, but earth connection is common. Okay, students, right? Okay, next, so few points for the domestic wiring. Okay, so the first one, the live wire has high potential of 220 volts. 220 volts. So the voltage of our home power is 220. Yes, whereas The neutral wire has zero potential. Neutral wire has zero potential. Therefore, the potential difference between the live wire and the neutral wire is 220 minus 0. The voltage is 220 volts. Right. And the earth wire is much thicker in size and it is made of copper. So the earth wire is made of copper, and one end of it's connected to a copper plate buried deep under the earth. The earth connection is made to the electric meter and then to the main switch. Yes, and in our homes we receive supply of electric power through the main supply and either supported through overhead electric pulses or by the ground wire cables. If you go to cities, all the cables are underground cables, but in our country, most of the electric power is through the electric pulses. That is street pulses. Okay, that is street poles. Street electric poles is nothing but current கம்பின்னு சொல்லுவோம் இல்லையா, sorry, the pole. Okay, that's why. Yes, continuation. The live wire and the neutral wire coming from electric pole, street pole, right, enter a box fitted just outside our house which has main fuse. The fuse is connected in series with the live wire, so the fuse is always connected in series with the live wire, and the fuse has high rating about 50 ampere. So yes, 50 ampere, the range of the fuse is 50 ampere, right? And okay, thus is prevents any damage such as fire to enter electric wiring entering the house due to short circuit or overloading the two wires, and then enter the electricity meter which records little electric power consumed by us in kilowatt hour. So kilowatt hour, electrical consumption is denoted by kilowatt hour, right? And this meter is installed by electric supply and department of our city. Yes, the department is nothing but EB board, yes, electrical board. Okay, and now these two wires coming out of the meter are then connected to main switch which is placed in distribution box, and another fuse is placed in series with a live wire in this box for the sake of consumer safety. And there are two separate circuits in our house, namely lighting circuit and power circuit. So there are two circuits in our homes. One is lighting circuit, another one is power circuit. Okay, lighting circuit for fan, light, these and all lighting circuit, and power circuit different purpose. Now see this, the sub circuit in domestic wiring, that is types of circuit. One is lighting circuit. The lighting circuit is nothing but light and fan. Yes, now see the lighting circuit, the sub circuit of the electrical installation feeding supply to various light points, for example lamps, lighting cable, and lighting switches. Yes, in the tubes. Okay, tube like this and all, and to fan points is termed as light and fan sub circuit respectively. Okay, so light, fan, and the other lights are under lighting circuit. Now come to the power circuit, the part of complete installation that supply appliances like a hot plate, electric iron, a small single phase motor of washing machine, refrigerator is generally called as power sub circuit. Okay, so fridge, washing machine, mixie, micro oven, so இந்த பாயிண்ட்ஸ்க்கெல்லாம் யூஸ் பண்ணக்கூடிய சர்க்யூட் என்னன்னு நம்ம சொல்லுவோம்னா பவர் சர்க்யூட்னு சொல்லுவோம். ஓகே, ரைட். Okay, and do you know, yes, in our book do you know this information, from this information 1 marks will come. Okay students, and see this, In India, domestic circuits are supplied with an alternating current of potential 220 voltage to 230 voltage. 222 and 230 voltage, the frequency of the current is 50 hertz. But in countries like USA and UK, domestic circuits are supplied with alternating current of potential is 110 voltage. 110 voltage to 120 voltage, but the frequency is high, 60 hertz. So if you go to USA, the voltage is 120 voltage, right? But the frequency is 60 hertz. Okay, students. So 2 1 marks. In India, what is the voltage? 220 to 230 voltage. But if you go to USA, what is the voltage? 110 or 120 voltage. Okay, students. Right. Next, earthing. Yes, earthing. Right. So what is earthing? The process of connecting metallic bodies of all the electrical apparatus and equipments to huge mass of earth by wire having negligible resistance called as earthing. Yes, all the ones are yes connected to earth. Yes, that is earthing. Okay, if suppose if any circuit having high voltages, leakage of voltage will be takes place. That leakage of voltage connect passed through the human being, it will be some small shock, so that is earthing. Okay, right? Earthing system, right? See this, all the people living or working in residential, commercial and industrial installations, and particularly the operators and the personnel who are in close operation and contact with electrical system and machinery should essentially protected against possible electrification. That means to achieve this protection, earthing system of installation is defined, designed and installed according to standard requirement. Standard requirement. So due to avoiding is a shock, definitely have to use a earthing system. Right? Earthing system. Yes, good earthing means. Okay, good earthing is perfect earthing. That is a good earthing. See this, a good earthing must have low impedance enough to ensure that sufficient current can flow through the safety device so that it disconnects the supply. Yes, disconnect the supply. Say for example lesser than 0.4 second, and okay, and fault current is much more than full load current of the circuit which melt the fuse. So hence the appliance is disconnected automatically from the main supply. So we are using trippers. Yes, trippers we are using. Okay, that electric shock. Yes, without earthing we felt some shocks. Okay, if it is high voltage is present in that equipments. Okay, now see this, an electric shock occurs when two portion of a person body comes in contact with electrical conductors of a circuit which is different potentials, so thus producing a potential difference across the body, right? And the human body does have resistance, and which when the body is connected between two conductors, a difference, a circuit is formed through the body and the current will flow, right? And when the human body comes uh, contact with only one conductor, right, and a circuit is not formed and nothing happens. So when the human body comes in contact with circuit conductors, no matters what the voltage, there is no potential for harm. So this is just few details about electric shock. You don't worry about that these details. Okay, this is extra points. Okay, okay students, right? Now come to the next topic, LED. What is LED? LED is nothing but light emitting diode. Light emitting diode. Okay, see this, light emitting diode is a semiconductor device that emits visible light when the electric current passes through it. So the light is not particularly bright, but it most LEDs it is monochromatic. Monochromatic means it emits single color. Yes, it will produce single color and occurring at a single wavelength. So light is a semiconductor device. Which light? LED light. That is LED. Yes, bulb. Semiconductor device that LED emits the light. Okay, if the current pass through the LED. Okay, students, right? And the continuation. So this is the LED, right? And the LED converts electric energy into light energy. LED convert electric energy into light energy. They are frequently used as a pilot. Yes, and lights in electronic appliances to indicate whether the circuit is closed or not. Okay, so LEDs are used in electrical circuit to indication purpose. And see, this is the different types of LED. Yes, so this is the LED screen, and this is number system LED, and this is the signal LED. Okay, so these are the different types of LED system. Next, appliances. The LED is used in various field. The one is the LEDs are used in sensor applications and used in mobile applications and used in signal applications and LED signals and the signal application and illumination systems, and they use it as a indicators. Use it as a indicators. All the indicators nowadays are LED. Which one? LED. Okay, students, right? Now, so this is the 7-segment display. 7-segment display. So this is the light, and this is only the LED. Is 7-segment LED. See this? What are the 7 segment? See this? This is one segment. 1, 2, 3, 4, 5, 6, and 7. So this is 7-segment LED. All the numbers are 7-segment LED system. Okay, students, right? So what is 7-segment system display? The 7-segment display compresses 7 LED and LED for decimal point. For example, little than in order can forms different letters and alphabets. So letters and alphabets all are displayed with the help of 7-segment LED. Okay, and the 7-segment LED display system is special for displaying numerical characteristics or numerical character, right? And there are two types of 7-segment display. One is common cathode 7-segment display, another one is common anode 7-segment display. So there are two types. One is common cathode and common anode, right? Okay, students. And merits of LED bulbs. Merits of LED. Some merits, no. Yes, see this, as there is no filament, there is no loss of energy in the form of heat, so it is cooler than in-hand lamp. So it is cooler than in-hand lamp, right? That is ordinary bulb. And second point, in comparison with the fluorescent light, the LED bulb have significantly low power consumption. So all the LEDs are low power consumption, right? And third point, it is not harmful to the environment, so that is eco-friendly. A wide range of colors is possible here, so there are n number of colors, and it is cost efficient and energy efficient, so low cost material, right? The sixth point, mercury and other toxic metals are not required, so toxic metal not using making of LED. Okay, and one way of overcoming the energy crisis, it is used to more LED bulbs. Okay, this is the merits of LED, light emitting diode or light bulb. Okay, students, and now next, LCD or LED, which is one. So this is one monitor, right? LED TV. Yes, LED TV. So it is nothing but light emitting diode based on the video display. So these LED TV displays are not an entirely new technology, but is a variation of LCD displays. So LCD TVs are used cold cathode fluorescent lamp, CCFL, right? Cold cathode fluorescent lamp, and while LED use light emitting diodes. So LCD liquid crystal display and LED is light emitting diode display. So that is the different. Okay, now an LED TV use less power and provides a brighter display with better contrast and thinner panel and lesser heat dissipation than the conventional LCD TV, right? And this is because LED TV use light emitting diodes for backlighting as opposed to the CCFLS for conventional LCD TVs. And the display of LED TV, it is not an LED display. So a more technology is and technically correct, the name for it would be LED backlit LCD television. Okay, students, continuation. RGB, dynamic LEDs. So what is R, red, and what is G, green, what is B, blue? So these are the RGB, and then RGB dynamic LED show true blacks and whites and thus get higher dynamic contrast ratio at cost of less details in smaller bright object on the dark background. So white LEDs are less costly, and while red, green, and blue LEDs provide richer color gamut. So it gives the high power, color, rich color, high color contrast. Okay, and LED TV offer more colors, especially ones that use REG LED backlighting. Okay, so LED TV, it gives more brightness and more colors, right? And come to that plasma TV comparison between the LED TV. Yes, see this plasma TV, best for black rooms and best for bright rooms. LCD TV for bright rooms, and good picture quality, and here less picture quality than plasma TV. And come to this side, consume more space, but here LED TV consume less space, and here plasma TV less expensive than LED TVs, expensive than plasma TV. LED is expensive than plasma. Now it light themselves using gas, yes, using gases, but it lights the screen using light emitting diodes. Okay, okay student, there is a difference between the plasma TV and LED TV. And now come to the advantages, right? So there are more advantages. Yes, the first one is power saving. The LED backlit TVs are more power efficient than traditional LCD TVs, and although regular LCD TVs are relatively efficient, but the LED cells simply produce more light power watt than fluorescent. So this can result in power saving approximately 40%. So ordinary TV consume more power than LED TV. So LED TV, if you use the LED TV, the power consumption is lesser than ordinary TV. Okay, and now a better contrast. Some LED backlit TVs are capable of generating better contrasts through the use of local dimming. And the local dimming is when the LED behind dark part of the picture are either dimmed or left off. So doing this can increase the appearance of contrast in the image. And now the more accurate color, see this, the LED black TVs can offer rich color than LED panels, and this can be accomplished through slightly modifying the color of the white light emitted by LED TVs to compensate for LCD shortcoming. A more advanced, yes, a more advanced solution comes in some Sony Bravia models, which use a multicolored blacklight to reinforce the image on the screen. So this is the more accurate colors details. And now come to the smaller in size. So because the LED are smaller than CCFL tubes, so LED TVs can be thinner than traditional LCD TVs. In addition to this, TV that are edge, it is placed their LED backlights on the side and making it possible for them to even thinner than regular LCD TV. So LED TV is very thinner than LCD displays. Yes, okay. So these are the advantages of LED display or LED TVs. Okay, students. Okay, thank you, students. So unit 4 theoretical side is over with example problems also. Okay, students. Okay, if you have any doubts, just call me. Okay, students. Thank you, students. We'll see you on next video. Thank you.